Hi, my name is Dan Gryffin. I'm the unlucky guy who gets to follow Joanna. So please bear with me. Also, obviously I will be speaking in English because Polish is not an option in my case. So if I say something confusing or if I start going too fast, will you please stop me? And aside from that, I hope that you'll just ask questions. The lights are kind of bright, so I may not see them right away, but please don't hesitate to ask questions in the middle of the talk. I think it's more interesting to be interactive. I'm a software security consultant. I'm based in Seattle, Washington, in the United States. I'm conducting an informal scientific poll. Seattle is 12 hours of flying time from here. Did anyone have to fly more than 12 hours to get here? Oh, back there, where'd you come from? Oh, that doesn't count. I'm talking about like yesterday and you still have jet lag. Okay, so he feels my pain. Thank you. Okay, I'm going to talk about hacking Windows Vista security. When I say hacking, this is from the perspective not so much of trying to compromise the operating system, but more from a learning perspective, trying to understand how certain security-related components of Windows Vista work. And so, to that end, I'm going to talk about 3 tools that my company wrote last year for Microsoft to become MSDN SDK samples. So if you're a Windows programmer, you can download the libraries and headers from Microsoft, and it also comes with a bunch of sample code for you to kind of bootstrap your learning about a feature that you're trying to implement something for. This is some of that sample code. So I think what's interesting about these samples is that they're actually like real for the most part. Some of it is a little bit contrived, I admit. I'll get to that in a second. But anyway, for the most part, these are like real security tools, which is pretty unusual for sample code, especially sample code that you see from Microsoft. I'm sure you guys know that it tends to be pretty weak for the most part. So I'm really happy that Microsoft is now showing interest in providing real tools for people to learn from, for people to play with, of course, the source code available. That's also unusual. These tools are all C and C++, so I'm not going to be showing any C and C++ here. I don't want to scare anybody off. But in order to play with the tools, aside from just running them, in order to be able to kind of adapt the tools, you'll definitely have to be comfortable with C programming on Windows. However, everything that is required in order to do that is free. The SDK libraries and the include files are free. The source code is free, and you can get there's free versions of Visual Studio now. I think it's called Visual Studio Express Edition. Now, of course, Windows isn't free unless you download it from a Wares site, but that's your problem. That's not my problem. Okay, I'm going to talk about crypto, the firewall, and IPsec. One other thing. In the talk proposal, there was a 4th topic about smart cards, and I apologize if you came here to hear the smart card piece. After I responded to the call for papers with that piece, the vendor, even though I wasn't naming the vendor in my talk that had a bug, and even though I'd done responsible disclosure about a year ago, the vendor got really mad at me for talking about that. And they asked me not to talk about the smart card bug, so I'm not going to talk about the smart card bug, the smart card tool that I wrote. It was a smart card fuzzing tool. If you're interested in that, if you work in smart cards, if you work in multi-factor authentication, or if you're interested in fuzzing tools, please come talk to me offline, and I can just kind of give you a description, high level, of what I did and what my results were. Or you can send me an email. I'll have contact information at the end. Okay, the first tool talks about hacking crypto. So what I wanted to do is, I think what's interesting about Windows Vista from a developer's perspective, and also actually from a security engineer's perspective, is that there's a lot of extensibility that's new to the operating system in Vista. So there's all these new ways that you can plug in. And of course, that has ramifications from a security perspective, because those are new entry points in the operating system that have to be secured, A. B, that means that third parties who take advantage of those entry points, take advantage of those extensibility features, if you're an administrator, you kind of have to worry about whether they did that securely, right? Whether they knew what they're doing. And as with anything, there's a learning curve. And so what you're going to see is that the first version of programs that take advantage of these new features maybe aren't necessarily going to get everything right. So that's part of my goal here, is to provide some samples of the right way to do things. And I was able to do that because since I was working on contract with Microsoft, you know, I get to have access to the product group and I get to ask questions and stuff like that. Okay, so what's CNG? CNG is Crypto API Next Generation. That's basically the new cryptographic API for Windows Vista. There are a couple of goals in that API. One of which is to make it so it's a lot easier to add new algorithms to the operating system. I don't have to tell you guys, since this is largely a Europe-based crowd, there are lots of crypto standards that you find in different parts of the world, the vast majority of which are not implemented out of the box in Windows, or most operating systems for that matter. So one goal in creating this new API, this CNG, is in recognition of the fact that, for example, every government in the world, even though many governments have started using Windows for non-classified systems, they still have to have their own encryption algorithms and stuff like that they need to be able to plug in order to deploy those systems. What's CMS? CMS is the cryptographic message syntax. That's basically an IETF standard, for example, that applies if you're exchanging digitally signed or encrypted email. And then, apologies for these nasty hyperlinks here. Again, I'll have a link at the end that's a little bit shorter that'll point you to all these things, all these resources. So I wrote a tool and the sample code that shows how to add a cryptographic algorithm to Vista. That tool is called TF-Test. I realized I skipped a bullet in the previous slide. TF stands for two-fish. Two-fish is a symmetric crypto algorithm. It was invented by Bruce Schneier and his group. It was one of the entrants for the advanced encryption standard back in 2000, and it didn't win. The algorithm called Reindel won. But two-fish is still considered to be secure. It's been reasonably well cryptanalyzed. It's held up. Two-fish actually is supported like by some Linux tools, like GPG. Some version of GPG might use it. I don't know, can anybody second that? Anyway, I've seen it in the wild. And I thought, okay, well, this is an interesting one because it's an algorithm that I've actually seen deployed. It's not supported by Vista. And it so happens that there is two-fish sample code that's IP-free. There's no patent issues or whatever that I was just able to download off the internet, and it just works. So that was kind of convenient. Anyway, what I did is I wrote this tool, TF-Test, to kind of simulate what Outlook or Thunderbird would do in order to send an email encrypted with two-fish. So the plugin I wrote, aside from this test driver, TF-Test, the plugin I wrote is called twofish.dll, and that plugs into this new API. You can see an arrow 2 on the bottom left there. That plugs into this new API called CNG. And CNG interacts with this other API that's built into the operating system called CMS, this cryptographic messaging API, which is what Outlook would use, again, in order to encrypt an email. I'm sure no one here trusts any algorithm that your government tells you should use, right? Because they all have backdoors. Everyone knows this, right? Okay. Okay, so that was my test program right there. That was the whole thing. Let me tell you what that did. I've already installed twofish.dll. I'll show you. It's in my it's in my Windows directory. Okay, so I installed my twofish.dll, I registered it, and then I run my test program, which is simulating Outlook. And of course, the reason I'm not actually using Outlook is that this is my work laptop, and I don't even trust my own sample code to not crash my work laptop. So anyway, there's a little disclaimer right there. You should take that into advisement if you want to try this. I pretend that I have a recipient certificate, so I'm going to send email to one of you guys. I somehow acquire your certificate. I realize that's a non-trivial problem, but anyway, we're skipping over that. I create a 256-bit twofish key with the new code that I just registered. And I encrypt a test message. This is a short test message to encrypt, quote unquote. Okay, and that's the end of pretending to be the sender. Now I pretend to be the recipient. And as the recipient, I use my private key to decrypt. This is with this CMS API. I decrypt that twofish key, and then I use the twofish key to decrypt the message. And of course, really the whole purpose of the test program is just to verify that the round trip message is the same, which it is. Any questions about that? Okay, so much for crypto. Oops. Okay, the next tool I wrote was to demonstrate some of the new features of the firewall. The firewall is notable, I should say the Windows firewall. Everybody knows what a firewall is, right? Okay, yeah. Stupid question, sorry. What's interesting about the Vista version of the Windows firewall is that it's actually really much more programmable than previous versions of XP, most notably. In a number of ways. One is that via C, C++, COM, VB script, there's a command line program that's built into Windows called NetSH. All of those mechanisms actually allow you to create and manipulate firewall rules. And so if you're a system administrator and you've got a bunch of legacy applications that you're deploying to Vista, or I should say you're deploying Vista and you need to make sure that these legacy applications run securely. That's a better way of putting it. You have lots of ways for making that deployment happen, whether you want to write a script or whether you want your application developers to write some special installer GUI using the C++ APIs, etc. Not only that, I'm not going to show in this demo, but I did another sample where Vista actually allows third-party software companies to replace the Windows firewall using the same low-level network stack interfaces that the Windows firewall uses in order to implement itself, so to speak. And to be a little bit more concrete, there's a lower-level network API called the Windows Filtering Platform. And so if you're an antivirus writer or an anti-malware writer, or you want to write your own firewall, you're going to use that low-level API to do that. And that way you have the same tools that Microsoft does internally. This demo, the firewall demo, is actually a good segue if what you really want to learn about is that low-level API. This is a good way to start. Okay, so here's the architecture of what we're doing. This is really simple. Basically what I wanted to show, aside from what I just mentioned about learning about that low-level API, what I also wanted to show is that I'm sure anybody who's installed a network-aware application on Windows is acutely aware, first of all, that very few application writers configure the firewall correctly for you. In fact, I shouldn't even say that they configure it correctly. They don't configure it at all. You're expected to know what ports to open, how to lock down your system, and I think that that's a shame. I think that if you're an application programmer, like I am, that you should be setting up the firewall in a secure manner as part of your application installation, and then restoring the firewall to its previous state as part of your application uninstallation. However, I recognize that there's very little documentation about how to do that. So that was my main intent in writing this tool. This tool is called fwtool.exe, and it provides a command line interface for administrators configuring a firewall rule. But of course, the code that I use, the code that I show in that tool, is something that the application programmers could use to do that automatically, which is really what I'm trying to encourage here. So anyway, if you see arrow 1 in the middle of the diagram, FWTool is this command line tool. It's configuring the Windows Vista firewall, and that determines whether the socket client program, which you can see on top of arrow 2 on the left-hand side there, that determines whether the traffic initiated by that socket client is able to get through the Vista firewall on the listener side, and in arrow 4, whether that traffic is received by the TCP/IP stack on the listener and goes up into the application space, arrow 5 into STCP serve, which is, again, just a simple socket listener. Okay, so let me make that a little bit more concrete by showing you. So I'm going to run the socket listener. And look what happens. I didn't confirm that you guys can actually see that. That's actually reasonably large. Hopefully you can sort of see what's going on there. But this is an interesting feature of, well, this is one of the reasons that the firewall is lame. Let me put it that way. Because look at this dialogue. Imagine you're like not a security expert like you guys all are, but you're just an average end user. The gentleman before was asking a question about the average user. This is a perfect thing for that. What average user is going to know what button to click on this dialogue? No one. They're just going to guess, right? And are they going to guess right or are they going to guess wrong? Well, what they want to do is they want their application to run. And I think most users realize that there's a trade-off between functionality and security. And so they're going to go for the functionality and not for the security one. So for all the people in this room, that's bad. We need to solve that problem. So if your user ever sees a dialogue like this, you have not solved that problem. So let's suppose that I'm the user and I happen to guess incorrectly. In other words, I guess the secure one. And I say keep blocking. Well, that means that, you know, truly this application is going to be shut down. It's not going to be able to listen to any ports. Okay? But let's suppose that I select unblock, which is going to allow this application to open up and listen on a network socket port. Well, let's see what that means in terms of the Windows firewall rules that are created on behalf of that application automatically by the operating system as a result of clicking that button. This is the built-in firewall management console in Vista. Oops. I need to refresh again. Okay, and I searched for S. Hopefully you guys can sort of see that, maybe. I searched for S because STCP server is the name of the program that I ran on the command line. Okay, so let's just run through the columns real quick here. Are these rules enabled? Yes. What type of rules are they? They're allow. They're going to allow traffic. What's the program path? This is interesting. The full program path ends up in the firewall rule. That's an interesting feature because if I happen to run STCP server after creating these allow rules from a different place, a different hard disk or a different location on this hard disk, and the path is different, then it won't match the rules anymore. So that's good, right? However, this is not quote-unquote strong naming. In other words, if I were to take netcat and rename netcat to stcpserver.exe and run it, it would match the rules. So, as I understand, a feature that's being considered for the next version of Windows would actually be to do some sort of cryptographic identity of this program and bind that to the firewall rule, which I think would be pretty cool. That'd be a sweet feature. Okay, we have two rules created by default, and here's the moral of the story. The moral of the story is that those default rules allow this program to receive all TCP traffic, all UDP traffic on any local port from any remote address. Oops, I missed. Here we go. On any local interface from any remote port, any allowed user, etc., 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 etc. So those are pretty unsecure rules, right? We can do much better if we want to have a default rule set. And frankly, I think that the operating system could have had a much more secure default behavior. I think that's not good default behavior. But as I said before, I don't necessarily think that that's the operating system's problem. I think it's the application developer's problem. The application developer should have created a secure rule by default. So anyway, we'll show how to do that. Actually, before I show how to do that, I'm going to delete those rules. Sorry. Okay, delete the TCP rule, delete the UDP rule. Hopefully I deleted the right rules. I guess I'll find out someday. Okay, here's the command line tool I wrote for showing how to create a secure rule. Oh, that's kind of low. Sorry about that. Let me see if I can scroll down here. There we go. Okay, application name. I have to get the application name just right, because as you saw before, if I don't get it just right, the rule doesn't match. The program, one of the nice things my program is doing is it actually assumes that the listener is in the same directory that you're running fwtool, and it appends the full path, so you don't have to type out the full path. I don't know, you might actually consider that to be an obnoxious feature, but in terms of typing as little as possible for a demo, that was a pretty important feature in my mind. I think 27015 is the port number. Client address range, we're going to say local subnet. Local subnet is kind of another interesting feature of the operating system because it actually is a string. It's a special mnemonic that you can provide to the API, and then the TCP/IP stack in Windows will actually figure out what range of addresses that should really mean. So that's pretty convenient. Supposing you have a server that only people on your local subnet, on your local LAN, should be able to talk to that listener. You know, a database server or maybe a SharePoint or a wiki or something like that might meet that criteria. Okay, so I created that rule. Quick test to make sure that the rule matches. Yes, because I didn't get that prompt. I didn't get that confusing prompt again. So that means the rule matched. Let's go view it in the console here. I need to refresh the view again. There it is. Oops, looks like I did delete the wrong rule. Shit. That's really bad. Okay. I'm sure I'll get through the demo, but after that, who knows what's going to happen, right? Well, anyway. This rule here is the one that I created by the tool. Bear with me. Apologies for that demo bug there. Anyway, you can see that I got a little bit more of the metadata in the rule specified more tightly. So what I mean by that is you can see the rule I neglected to delete is actually not enabled. So anyway, that's fine. The one rule that is enabled is an allow rule. It's got the correct path. However, we're only allowing TCP traffic now, no UDP. We're only allowing STCP server to listen on a specific port, a single specific local port. We're only allowing this certain remote address range. You see some, oops, sorry about that. You see there's still some any's here. So I'm allowing any local address, any remote port, any allowed users, any allowed computers. Again, those are metadata that I can specify in the API. I just didn't expose it in the command line of the tool that I wrote. It would be trivial to add those features to the tool. So much for the firewall. Any questions about that? Do I think that developers should be configuring the firewall during the installation of the application? Yes, I do. Because so in general, you're going to have, okay, in my defense of that position, I should clarify that I understand that there's, when you talk about, you know, the range of applications, the range of network-aware applications that run on Windows, let alone every other operating system, it's huge, right? So do I think that that model will work for every single application out there? No, I don't. For example, you can have very complex applications where the developer can't predict exactly how you want to run that application. For example, the application may allow the administrator to specify a different port. Do you want to expose all that configuration logic in the installer? Or do you want the administrator to be able to change his mind down the road, but not have had to go through the step of configuring the firewall manually in order to be able to make sure things are in sync, right? So I think that there are definitely counterexamples for what I'm advocating. However, right now the norm is that even for your standard simple listener applications, developers just do not provide this feature. They don't provide this configuration step for you. And I also admit that there are lots of different firewall programs. So this API that I'm showing only works for the Windows firewall. It doesn't allow you to configure Norton's products. It doesn't allow you to configure Symantec. But the fact of the matter is, on Windows Vista, the Windows firewall is disabled by default. And so I think it's a simple matter for the application developer to say, well, okay, I know that the Windows firewall is enabled by default. Did I say enabled or disabled? It's enabled by default. So let me just do a quick check to see if this is the 90% case where it is enabled. And if it is, let me create a typical secure rule. Am I answering your question? Okay. Yes. It does, but as Joanna observed, the installer runs as administrator. Okay. What question back there? Yes, that's correct. That's correct. I get that question every time. That is a great question, and apparently I haven't adapted my presentation to anticipate that question better. I apologize for that. So, the observation is this: in order to modify the firewall rules, you have to be administrator on the system. That's right. But hold on, let me get there in a second. In order to modify the firewall rules, you have to be an administrator. If you're an administrator on the system, you can do anything, okay? We agree there. Okay, now there's the problem about all installers being administrator. So in order for this whole end-to-end thing to work correctly, on one hand, you need to have application developers doing the right thing to make it so that the application is going to work. But on the other hand, this is clearly depending on an administered environment. In other words, this is an environment where your system is locked down, where you have a tested suite of applications that are being rolled out by someone who knows what they're doing. Because that someone is going to say, okay, well, I realize that these installers run as admin, so I better make sure that this stuff that I'm installing isn't, crap, isn't some rootkit, isn't some security thing, right? Otherwise, it's incumbent upon the user to make that evaluation. And that problem is much bigger than just the firewall. That problem applies to anything you install on Windows. Okay, again, great questions. Thank you very much. Okay, last demo, last tool. Does everyone know what IPsec is? Another dumb question? Sorry. Okay, I'm going to tell you anyway. IPsec is a suite of protocols for securing IP communications by authenticating and/or encrypting each IP packet in a data stream. The reason I said that is because you have to keep in mind IPsec happens without TCP, okay, right? There's no TCP involved when you're doing IPsec. I know that's obvious, but sometimes people forget that. Okay, what are the WinSock secure socket extensions? This is another example of a new extensibility point in Windows Vista, a new toy that application developers get to play with. In this case, what this allows you to do is, for example, the socket listener program that I was just demonstrating. Well, these secure socket extensions allow me, before on the server, which I showed, or on the client, which I didn't show, before I connect to that socket, before I do that TCP connection, it allows me to apply some security metadata to that socket and say, hey, don't even initiate that TCP connection, don't even send the TCP SYN packet unless there's been a successful IPsec negotiation. Unless the connection is secure, don't do TCP. So that's pretty powerful. That's not something that you used to be able to do at the application layer. That's something that you only used to be able to do machine-wide. So there's lots of rope there for you to hang yourself with, so to speak. Okay, another big scary diagram. What I'm showing here is, again, kind of an adaptation of that firewall diagram, where I've got a simple socket client, a simple socket listener, two different machines. And on the left-hand side, on the client, I'm running this IPsec debugging tool, which is what I'm going to show you. That's what I wrote for the sample. It's called IPsec ping. It's basically ping on steroids. It's ping that allows you to debug IPsec connection between two machines. And what IPsec ping is doing is saying, okay, WinSock, which is the Windows Socket API, saying, okay, WinSock, don't open the socket unless you can negotiate a successful IPsec connection first. Arrow 1 shows that involves IKE. IKE stands for Internet Key Exchange. That's the key exchange protocol that gets you your agreed IPsec keys. That's the IETF standard. Arrow 3 shows that IP traffic, that IKE negotiation, is going back and forth between the client and server. And if that fails, you'll never get to, and then, sorry, arrow 4 shows IKE on the server side. So 2, 3, and 4 are that IKE negotiation going back between client and server. If that negotiation fails, arrow 5 will never happen. If that IPsec negotiation, if the IKE negotiation is successful, then arrow 5 is basically the initiation of the TCP connection. And once arrow 5 and arrow 6 happen, in other words, once I brought up the socket, that's really the whole point of IPsec ping, is to see if the socket is successful. If it is, it just immediately tears it down. If the IKE negotiation failed, the purpose of IPsec ping, or the benefit of IPsec ping, is to dump out as much debugging information as it can find. This was developed with my buddy William Dixon, who's a IPsec and IPv6 consultant. This was all his idea, but he's not a developer. Oops. Okay, so here's IPsec ping. I'm going to specify verbose mode. I'm going to specify IPv4 addressing. And I'm going to give the NetBIOS name, the DNS name of the VM that's currently running on my laptop. And we're going to pray that this works. For some reason, this demo has been taking a few seconds to initialize the connection. Hey, it worked. All right. So just for the record, that's a live IPsec demo running on a laptop with a VM. That's not something you see every day. Okay, so let me explain what happens here. I take the DNS name and I crack the name and I get an IP address. Okay, so this is the static IP I configured for the virtual machine running in VMware. IPsec ping assumes the default port. I'm sure everyone in this room recognizes this port number, 135. It's the RPC endpoint mapper on Windows. It's that lovely secure port that's always open on a Windows machine. Never any bugs with that port, right? Anyway, it's convenient because since it's always open, it's a good default to try to establish that IPsec connection with the server. Okay, the socket connection was a success. Great. We connected from a random high port on the local machine, on running native on the laptop, to 135 on the VM. And since the connection was successful, I'm not going to demonstrate the failed connection. That's too terrible. I'm going to only demonstrate the successful connection. Since the connection was successful, we can retrieve a bunch of metadata about that IPsec connection, about the IPsec, about the crypto parameters specifically that were negotiated between the client and server. So if you're a crypto weenie like me, you'll love all this like technical, it really looks kind of scary, doesn't it? The whole output of this tool, it looks kind of intimidating. I really enjoy that. Anyway, we're using triple DES encryption. We're using SHA-1 hashing. The key agreement was arrived at via Diffie-Hellman, curve suite 2 or whatever. I don't know what the specifics are of that Diffie-Hellman suite. Here's an interesting note from the attacker perspective. I used pre-shared key. In other words, I pre-configured the laptop in the VM with a simple static password to do the IPsec authentication between them. If you're an attacker and you have access to a machine that's part of an IPsec pre-shared key deployment, it is trivial to retrieve this pre-shared key value and then bring up another machine that's trusted in that IPsec network. So as an administrator, you should keep in mind that even though pre-shared key IPsec is pretty common, because some of the alternatives, or most of the alternatives, have been historically complicated to deploy, certificate-based is an example. Even though that's very common, there's a big trade-off here. So keep that in mind if you're doing pre-shared key stuff. Okay, anyway, then I display a bunch of other connection metadata about the IKE main mode security association, the IKE quick mode security association. As I said, the connection was successful. That's really all I cared about, so I immediately disconnect the socket. This output here is actually a lie. I did not delete the IKE main mode and quick mode security associations. When I was first writing this tool, I wanted to do that, and I couldn't figure out how. And I left that string in there, even though I never figured out how. However, I have since then figured out how. And so if you're interested in playing with this, and anyway, that's a feature you'd want, just let me know, and I'll tell you how to do that. And someday I'll update the code. Sorry about that. Any questions about IPsec ping? No. That's another great question. Thank you. The question was whether triple DES, to paraphrase, the question is why did it use triple DES? And that's again a great question. I really don't think it should have used triple DES. I have a feeling that's because of something in the IPsec standard, in the IKE standard, that triple DES is its default. Why it's not using 256-bit Rindell instead, since this is 2 Vista machines that I can guarantee you support the AES algorithm, I think that's a bug. I don't think they should be using triple DES. Now, I'm not saying that triple DES is insecure, but the recommendation of everyone I've talked to is that you should be using AES instead. And so that should clearly apply to something as critical as IPsec. So again, thank you. That's a good question. Any other questions about that? Okay, that's my email address, and you can find information in the downloads about all this stuff at my blog. That's all I've got, guys. Thank you very much.